Hello, this is Mrs. Pullen for Algebra 2. In this video, I'm going to go over some of the problems from the 25 Common Algebra 2 Regents question booklet. So we're going to start off with number 1. They ask you to completely factor, and we notice there's 1, 2, 3, 4, 5, 6 terms. And so when you have 4 or you have 6 terms, you should think about using grouping. Now, what's different about when you have 6 terms is sometimes you group in pairs and sometimes you group in threes. And my recommendation is always start by looking to see if the pairs work, and then afterwards, if the pairs don't work, then try tripling it up. So let's see if the pairs work. So I have a common factor of k squared in that first group, and I'm left with k minus 4. And in the second group, I have a common factor of positive 8k. And when I factor that out, I get k squared minus, well, this was also k squared minus 4, k squared minus 4. And in the last group, I can factor out a positive 12, and I'm left with k squared minus 4. So notice that I have a common binomial of k squared minus 4 with each of the terms. Therefore, I know the grouping work with pairs in this case. So I'm going to factor out that common binomial of k squared minus 4. And when I do, I'm left with the k squared plus the 8k plus the 12. And then I look to see if I can factor further. And I know k squared minus 4 can factor into k plus 2 times k minus 2. And then that trinomial, I can do that sum product method where I'm looking to see if it adds to 8 and multiplies out to 12. So what are factors that multiply out to 12 and add to positive 8? And that would be 6 and 2. So this continues to factor into k plus 6 and k plus 2. And that's my answer. So I have k plus 2, k minus 2. So I know it's not this one. And then I need k plus 6 and k plus 2. So it's not this one. And so when I look closely, that's choice C. I now want to do number 2. So this is our standard trig question. We call them bow tie problems. And the first thing I do is I want to sketch out an XY quadrant. I know that an angle in standard form, the angle lands in quadrant 4. So here's the terminal side of the angle. And from that point, I'm going to draw a perpendicular line up to the x-axis and form a right angle. Here's my reference angle. And I'm told cosine of theta is 7/12. So I think SOHCAHTOA, whenever I do trig, what you learned way back when, it really is used a lot. And I know cosine is adjacent over, oh, I'm sorry, it's 7/25. I don't know where I got the 12 from. Okay. So adjacent over hypotenuse. So here's my adjacent side, here's my hypotenuse, and now I have to find the vertical side. And so to do that, I'm going to use a squared plus b squared equals c squared. Good old Pythagorean theorem. So that's 49 plus y squared is equal to 625. I subtract 49 from both sides, so I get y squared is equal to 576. I now take the square root of both sides, So y is equal to plus or minus 24. So which is it? Is it positive 24 or negative 24? Well, since our vertical, we think of y's, is in quadrant 4, our y's are negative, so this would be negative 24. We're almost done with the problem now because now they want us to find tan of theta. So tan of theta is opposite over hypotenuse. So here's my opposite side, and I'm sorry, it's opposite over adjacent, and here's my adjacent side. So it's negative 24 over 7, and then I carefully look to see which choice, and that looks like choice D. Okay, problem number 4. So, I'm sorry, number 3. So Mia has a student loan that is in deferment, meaning that she doesn't need to make a payment right away, and the balance of her loan account during her deferment is represented by this function. So let's write down this function. So she's starting out with a loan of $35,000. Where x is the number of years. So x, that exponent, is terms of years. If the bank decides to calculate her balance showing a monthly growth rate, so now we want to go from annual to a monthly amount. Well, to convert years to months, you multiply it by 12. So if I multiply this x by 12 to convert it into months, in order to keep my function and the value of my function equivalent, I have to raise my base to the 1 over 12. So this would produce an equivalent amount because, like, if you raise a power to a power, you multiply the exponents, you would get back the original. So then in your calculator, you would keep the original amount at the a sub 0, but 1.0325 raised to the 1/12th, if you entered it in the calculator, you would get 1.02712x. And so that's choice D. I would like to do number 4, but I'm going to do that in a separate video when I can put out the calculator. I'm not going to do it tonight, though. I want to do number 5. We haven't done this one in quite some time. And just in case, it's been on a couple of regions, not the past 2 years, but that doesn't mean it's not going to be on yours. So we want to make sure. We've done inverses before, but this is a little trickier. So with any inverse function procedure, what you want to do is you want to first replace y by f of x by y. And now we switch x and y. Okay. And now what we're going to do is we're going to cross multiply because we're going to cross multiply. Is everything okay, Mike?
Yeah, she wants to go to the shop.
Okay. So we're going to cross multiply. And remember what our goal is at this point. We need to isolate the y's. So what we need to do is get like all the terms with the y's on one side and the terms with the x's on the other side. So I'm going to subtract y from both sides. And at the same time, I'm going to add 2x to both sides. So after, let me just take a step back. We went ahead, we replaced f of x with y. We then switched to x and y. At this point, in order to isolate y, we first cross multiply. So here, you're going to cross multiply. And that gets rid of the fraction in the denominator. We then are going, after we cross multiply, we're then going to get the terms with the y's on one side. So I subtracted y from both sides, and I added the 2x to both sides. So notice now the 2x plus 1, there are no y's in it, but here there's nothing other than terms that contain a y. Okay, so here's the next step that you have to watch out for. We're going to factor out that y. So this becomes xy divided by y is x, y divided by y is 1. And now, to get y by itself, we're going to divide both sides by x minus 1. And so y is equal to 2x plus 1 over x minus 1. And now we just put fancy notation. And now we look to see which choice matches, and we see it's choice A. Okay, problem number 6. So for problem number 6, they want you to take this function, which is currently in exponential form. So I'm just going to rewrite it so it's less gooky. And they want you to convert it into logarithmic form. Well, let's remember what each of the items is. Here's my base, here's my exponent, and here's my result. When something's in logarithmic form, the exponent is equal to log base b of n. So in this case, q is the exponent, and log means exponent. 2 base 1/2, the base is in the basement, needed to give you an answer of p. And then if we look closely, that's choice B. Seven is our typical long division problem, so I'm going to skip it. Notice it's on every single Regents. Number 8, this has also become typical, but I'm going to redo it. Here we have a parabola, and what they want you to do, and they also gave you the equation of the directrix, and they want you to find the coordinates of the focus. And so the way you want to do these problems is you really need to know this formula. And this, again, is fairly standard on the Algebra 2 Regents. So this is a formula you have to memorize. The vertex is h comma k. Notice you reverse the sign of what's inside the parentheses, but not what's outside of the parentheses. This is the x-coordinate of the vertex. This is the y-coordinate. P represents the distance from the vertex to the focal point or the vertex to the directrix. In other words, the vertex is directly in between the focal point and the directrix. So when they give you the equation, the majority of time what you want to do is you want to put it into standard form. And to do this, I'm going to put that invisible 1 back there. So I'm going to divide both sides by 12, and I get y plus 3 is equal to 1 over 12 x minus 4 squared. And now we're almost in like this regular equation form. I'm going to subtract 3 from both sides. And now I have this equation that's in standard form. So how does this equation help me? Well, one, I can determine the vertex of the parabola. So remember, we're going to reverse the sign of whatever's in the parentheses. So the x-coordinate of the vertex is 4, and the y-coordinate, you don't reverse the sign, is just -3. I can also find p. 12 is equal to 4p. Remember, whatever is in the denominator of that leading coefficient is 4 times p. And so when I do that and I solve for p, I get 3. I also know the parabola is facing upwards because there's no negative in front of the leading coefficient. At this point, I can sketch a graph because most of the time they don't give you graph paper for it. And so I know that my vertex is 4, -3, and I'm going to label that V. And I know my directrix is -6, so it's that horizontal line, which I label. And I know the distance between the vertex and the directrix is 1, 2, 3, which we know already. And therefore, from the vertex, we're going to count up 3, 1, 2, 3. And here's my focal point, and that focal point is 3, not true, 4, 0. So that's the vertex. And again, I don't necessarily have to draw my parabola in, but I normally like to. Remember, the parabola eats the food. For problem number 9, they're asking you to find the exponent. So they want you to get your expression, so it's y raised to whatever that exponent is. So first of all, notice that I'm taking the cube root of something. So when you're taking the cube root of something, in other words, you're raising it to whatever the nth power is, whatever the root is, it goes in the denominator. So that's 1/3. And it's times, and there's really like an invisible 1 under the y to the 4th, and you need that. I then raise a power to a power, so that becomes 1 over y to the 2/3 times y to the 4th over 1. And when I multiply across, I get y to the 4th over y to the 2/3. And then, of course, you remember your division rules. And so with your division rules, you keep the base and you subtract your exponents. So this becomes y to the 10/3. And don't leave your answer like that. What is n? N is 10/3. And I'm going to do one more problem in this video. We're solving, number 10, we're solving a radical equation. Make sure that you're first isolating your radical. Again, this is a fairly typical problem. All of these are typical. That's why I made this worksheet. When you raise a radical and you square it, I lost my x. You undo that radical, you pull the radicand out, and remember to multiply this out. So you get 49 minus 10x is equal to 4x squared minus 10x minus 10x plus 25. So 49 minus 10x is equal to 4x squared minus 20x plus 25. You're then going to subtract 49 and add 10x. So 0 is equal to 4x squared plus negative 20x plus 10x is negative 10x. 49 and 25 is negative 24. And at this point, I know everything is divisible by 2. And just to make it easier to factor, I'm going to do that. And I get 2x squared minus 5x minus 12 equals 0. Now, at this point, there's so many different ways of factoring this. You could use the quadratic formula. Don't leave it blank. I'm going to use split the middle, not because it's my favorite method, but I know many of you like it. Now, with split the middle, you multiply A times C, the first term times the last term, and you get negative 24. And you're looking for it to add to B, that middle term of negative 5. And so when you come up with the factors, negative 8 and 3 work. And split the middle is what it sounds like. You're going to take that negative 5x and you're splitting it into negative 8x plus 3x minus 12. And now we form a grouping problem, which most of you are getting very proficient in. So 2x times x minus 4 plus 3 times x minus 4 equals 0. You factor the x minus 4 out, that common binomial, and you get 2x plus 3 equals 0. One solution is x is equal to 4, and the other solution is x is equal to negative 3/2. Now, I've done this problem earlier today, so when I check my answer, the 4 works, and the negative 3/2 does not work. It's called an extraneous root if it doesn't work. In other words, you come up with a solution, but when you go back to check that solution, typically it doesn't work, and that's why it's considered extraneous. And so the answer to this particular problem is 4. Have a nice evening, and I will see you soon.